Hello everyone, and today we're going to learn about ratio and proportion. What is a ratio? So a ratio is just comparing two numbers or two values. So as a simple example, you have a class that has 8 boys and 12 girls in it. The ratio of boys to girls would be 8 to 12. And you can express that as a fraction is pretty common, just 8, as a fraction like 8 over 12. Or you can also express it in a few different ways. You can express it using a colon, and you just read that 8 to 12. And you can also write it in words. You can say 8 to 12. But however you write it, you should remember to simplify, to reduce your fractions or just simplify your ratios. So in fraction form, that would look like 2/3. In this colon notation, you would write 2 to 3 or 2 to 3. Okay, just covered that. Now, think about this. What's the ratio of 3x to 5x? If you think of it as a fraction, it might be a little easier. If you think of it as 3x over 5x, well, what would you do with that if you were going to simplify? Well, you'd cancel out the x's and say that that's just equal to, that's messy, to 3/5. Well, we're going to use that concept, right, that no matter what, if you have 3x to 5x, something's in the ratio of 3 to 5, you can express it as 3x to 5x. So we're going to use that to solve problems like this one. So we have the measure of 3 angles in a triangle are in the ratio of 2 to 2 to 5. So this sort of trick, if you will, is that if we express the first angle as 2x, and the second angle as 2x, and the third angle as 5x, we know that no matter what x is, those 3 angles will be in the ratio 2 to 2 to 5, which is what we want. Now, what's an equation we can write with 3 angles? Well, we know they have to add up to 180. So we're going to simply write that equation, that the first angle plus the second plus the third must add up to 180 degrees, and we can solve that simple equation for x. So we have 9x equals 180. So x, let's try that again. So x is 20. And then if the question asks to find the measure of each angle like it does, we'll just plug that back in, and we'll get 40, 40, and 100 as our 3 angles. There you go. Now, a proportion. What's a proportion? Proportion is just an equation that compares two ratios. This should be review. You should have experience with this before. If you want to solve a proportion, like the one you see here, you probably are familiar with a shortcut called cross-multiplying. Just quickly to show you why cross-multiplying works. It's not just a magic trick. What you're really doing is just multiplying both sides of the equation by the denominator. So if you wanted to clear out that 3, you'd multiply both sides of the equation by 3. Those 3's cancel out. And then to cancel out the x's, you'd multiply both sides of the equation by x, which would cancel those out. And what you're left with is 2 times the x on the left and 3 times the 4 on the right, which is of course what you would have gotten had you simply cross-multiplied, had you simply multiplied those two together and set it equal to those two multiplied together. So to finish that off, we have 2x equals 12 and x equals 6, and that's solving a proportion. Now another example where we've got more than one x, you're still going to use that cross-multiplying trick. Just make sure you distribute. So when we do the numerator times the other denominator, 3 times x plus 2, you've got to distribute. So that's 3x plus 6. And then the other way, the denominator on the left times the numerator on the right, 4 times 2x minus 1, that's 8x minus 4. And now you've got a pretty easy equation to solve. Subtract the 3x from both sides, and add the 4 to both sides, and then divide by 5. And again, we get a pretty easy equation to solve. Okay. Now, some properties of proportions. Some of these are pretty straightforward, and a couple of them are a little unusual. So if you have a proportion that looks like this, A over B equals C over D, or A is to B as C is to D. Of course, this first property here is simply what you get when you cross multiply. A times D is equal to B times C. So that one's pretty straightforward. Right, so if this is true, then you know this one's true. If you look at B, all I've done is switch these two numbers around. Well, if you think about what happens when you cross multiply, in fact, that's usually the easiest way to see if these are equivalent. If this equation is equivalent to this one, what happens if you cross multiply? Well, you're still going to be multiplying A by D, and you're still going to be multiplying B by C. So we see that these two numbers are interchangeable. It's basically what this property is saying. And likewise, it could have interchanged those two, and you'd still have an equivalent proportion. Okay. For C, that one's just flipping those fractions upside down. And again, we're looking for equivalent proportions. And we see that, again, if you cross multiply, you get the A times D equals B times C, which is going to give you the same answer. Okay. This one is a little bit different. It's kind of an unusual one that you might want to memorize. I do want to quickly show you why it works. And I'll show you first with an example with numbers. So let's just say you have a fraction like 2/3, a proportion like 2/3 is equal to 4/6. Of course, you know that's true. Those are equivalent fractions. So looking at D, if 2 is A, 3 is B, 4 is C, and 6 is D, fitting with the original statement, what that would look like here is A plus B would be 2 plus 3 over the original denominator, and C plus D would be 4 plus 6 over the original denominator. Well, let's see if we still get a true statement. We know this one was true. Let's see if this one's true. Well, this side on the left is 5 over 3. This side on the right is 10 over 6. And if you reduce that, you get 5 over 3 that's equivalent. So it still works. Basically, the reason why that works, I'm running out of space here, so I'll show you quickly why that works. Here we go. So the reason that works is that if you start with A over B is equal to C over D, think about this. Is it okay to just add 1 to both sides of an equation? Of course it is. You can add anything to both sides of an equation and it doesn't change it. Well, if on the, I'm going to rewrite it because it's getting messy. If the part on the left, the A over B, if I simply add B over B, which is 1, and on the right side, I'm starting with C over D, and I'm also going to add 1. I'm just going to add it in a different way. I'm going to add D over D. All I've done is taken this original equation, added 1 to the left and 1 to the right. I've just done it in a clever way. And if you add those fractions together, if you simplify the left, we've got a common denominator. That becomes A plus B over B. And on the right is C plus D over D. Now you don't have to, you're not really responsible for knowing why that works, but I like to show you. Okay, one more property you need to know about. This one's really kind of funky looking. If you have a bunch of equivalent fractions, which is all this is, then essentially this sort of violates the rules of adding fractions. Basically, when all these fractions are equivalent, it's saying you can add all the numerators together, add all the denominators together, and you get an equivalent fraction to the original ratio. Yikes, that sounds crazy. Let me show you with numbers and it'll make a lot more sense. Let's say we have 1/2 is equal to 2/4 is equal to 3/6. I think you'd agree those are all equivalent fractions, equivalent ratios, that's all true. Okay, well now let's see what that looks like here. If we add those numerators, 1 plus 2 plus 3 on the top, and then add those denominators, 2 plus 4 plus 6 on the bottom, what happens? Well, on the top we get 6, on the bottom we get 12, and what is that? It's still 1/2. It's equivalent to the others. So it looks kind of strange, but hopefully you can see there that this is in fact true. And that's all for today. Thanks.